We're going to continue with a few of the trig graphs, because what you're going to get is you're going to get graphs intersecting each other and points given and be asked to work out the period, etc., etc. So let's just establish, first of all, the general forms of some of these graphs, shall we? Well, as you know, where we were last is we were talking about the standard form. And we had got, just get that there. And remember, we'd got either f of x in function format or in equation format equal to a times sine of x plus q. Now, not the last, but now we said we're going to bring in this dreaded p again. We're now going to change it to f of x equal to y equal to a sine of x plus p, okay, plus q. Now remember, p and q can be negative numbers. If q is negative, it means we shift down. The whole graph moves down, right? No, we don't do funny sort of graphs that blow up and all kinds of things. With this, all we're going to do is we're just going to move it down or up by an amount, okay? Then the next thing we're going to do, we're now going to look at this x plus p. There is only one way to do it, and that way is to draw a little table. Let's take a straightforward plot, okay? And let us plot y equals, let's first of all have our input value of x, 0, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. And we're going to have here y is equal to sine x, and over here I'm going to have y equal to sine of x plus 15 degrees. Okay, let's see what it does, shall we? Right. First of all, what I'm going to do is I'm just going to put in a 15 and a 30 degrees over there, okay? And yeah, let's just put that in like that, shall we? Now, let's just see what happens over here. 15, 30, 45, 45, 15, 60, and let's put in a 75. Just for completeness sake, right? Let's just put in some numbers here and see what's happened, right? Okay, here we go. There's my x values. Actually, that's just to correct it. X equal to that. Now I'm going to, you know what I'm going to do? I'm going to just open this a little bit to clear it, and I'm going to put y equal to sine x there. Well, if I put sine of 0, I get 0. Sine of 30 was 0.5. Sine of 45, 0.707. Sine of 60 was 0.866. Okay, I haven't got sine of 45, so let me get sine of 15. Sine 15 is equal to SD 0.2588. That doesn't look good, does it? 0.2588. And sine of 75? Sine of 75 is 0.966. And there is 1. Okay. Now we plot x plus 15. So if x is 0, the sine of 15. So I'm going to read 0.2588 over here. So sine of 15 is going to be the sine of 30. So that's going to be 0.5. Can you see that what has happened here? Okay. 0.866. 0.966, and that's going to be a 1. So what do you think is going to be over here? It'll be the sine of 90 plus 15, won't it? Okay, 90 plus 15 is 105. Okay, let's look at what the sine of that is going to be equal to 0.966. So yes, this is going to be 0.966. This is then going to be 0.866. So they've shifted. Okay? So therefore, the P, let me write it underneath here. Okay? Get rid of U and put P indicates a shift. Now we need to say, okay, which way? Now let me just plot this graph over here quickly, shall we? Just between there and there. It was 0.258, all right? And we went up to 1, okay? And then we came down like that. So this was my original y is equal to sine x, okay? Now I'm going to draw in red y is equal to sine of x plus p. P was equal to 15, remember? We added 15. So can you see that what has happened here is at 0, it's 0.25. Well, let's just go at 0, it's 0.25. Okay? And this was my old 90 degrees. So at 90 degrees now, it's 0.966. At 90 degrees, it's 0.9. So what has happened is, where's my peak? Let's find it. It's at 75. Whoops. So my peak is at 75 degrees, like so. Okay. This is going to be at minus 15 over there. Right? So what have we done? Okay. We have shifted the graph. We have shifted the graph by P to the left. Critically important. Let's just put it down again. So therefore, y is equal to sine of x plus p. P greater than 0. The graph goes to the by p. Okay. If p is less than 0, the graph, I'm going to say, goes back, goes forward by p. So if I had x minus 45 degrees, all my points move forward. Okay, so an x minus, okay, if p is positive, the graph goes backwards, okay, and if p is negative, the graph goes forwards, to the right, to the left, okay. Now, the only way to look at these is actually to draw them. If you draw these graphs, okay, just take, for example, 3 graphs. Let's do here, y is equal to, f of x is equal to sine x, f of x is equal to sine of x plus 30 degrees, and sine of x minus 30 degrees. And what do? We go and we plot these graphs. Okay, what do we get? This is what we eventually end up with over here. Okay, and all I'm drawing is I'm drawing this between 0 and 180. So I've got, what did I put here? 30, 45, 60, 90, 30, 45, 60, 90, 120, okay, 120, 135, 150, and 180. Okay, so basically all I did was that 30, 60, 90, oh man, Kevin, 30, can you see, I can't even add 15, say, 45, 60, that's 30, 90 degrees, okay? If we draw the straightforward original y equals sine x, we know that at 90, we had a peak of 1, and our graph did this, didn't it? Okay? It went like so. Okay? Now I'm going to draw the graph. Sorry, let me just go back on that. That is y is equal to sine x. Now I'm going to draw the red graph. I'm going to draw y is equal to sine of x minus 45, okay? and now sine of x, and y is equal to sine of x minus 45 degrees. Sorry, I seem to have changed my mind over here for some reason. Plus or minus 45s. Okay. Now I said if it's positive, it's going backwards, right? If it's positive, it must be going backwards, right? By the amount. In other words, if it's positive, so y is equal to, let's do the blue, okay? Y is equal to sine of x plus 45. It means it goes 45 that way, which means that goes to there, and my whole graph moves 45, okay, to there, whereas that was there. The 0 was at that, so now it moves 45, 180 minus 45, whoops, okay, whoops. All right, let's go 180 minus 45. 135 is my new 0 point. So, and I have moved, so that's going to be there. Okay. Can you see? So this is going to be moved 45 that way. Okay. Backwards. P is greater than 0, therefore the graph goes back by P. Sine of x plus 45, I'm going to take each point of importance, which is this one, and I'm going to move 90, goes to 135, right? And this moves to there. So this is going to now come up here and go down there like that, right? So this is moved. P equals minus 45 degrees. Therefore, if it's P is less than 0, the graph goes forwards, okay? And just to finish that off, okay? P is plus 45. P equals plus 45. So you actually have to draw them. There's no other way, okay? Once you've drawn one or two, and then remember, okay? Just remember here this, well, let me just rewrite it again just for the heck of it. Okay, y is equal to, that's not the way it should be. I needed to have it in my black pen to start with, right? Y is equal to a sine of x plus p plus or minus q for the moment. So therefore, if p is greater than 0, graph shifts backwards by P. If P is less than 0, okay, in other words, negative, that's positive. Graph shifts forwards by P. Okay, very, very straightforward. Just draw, like I've done there, take a cos graph, for example, and draw it with cos of x plus 45 and minus. Just draw the first bit, okay? Because in the exam, no, they're not going to give you from minus 360 to plus 360. They're going to give you a restricted domain interval over which to work, okay? Because it just gets too big to handle, number one. But they want to know that you know what you're doing, not that you can do it 3 or 4 different times, because it's just repeating itself, okay? Right. Now, the last thing that we can do is we can have the last change is, remember we started with y is equal to sine x, okay? Now, what if we had y equal to sine of kx, okay? K can be greater than 1. K can be less than 1, okay? What does k do? So what is y is equal to sine of 3x, or y is equal to sine of 1/3 x, all right? K can be minus. I'm going to put k greater than 0 as a fraction for the moment, right? Okay, so what does it do? All right, well, if you go and draw it, all right, if you did a drawing, let's just have a look again. Okay, here's my standard sine graph coming through there, right? There we go. Okay, and we've got our 90 degrees there, 180, 270, and 360 degrees. That's what the standard looks like, okay? Just get used to quickly sketching them. Works like a charm, especially now with all of these things that have changed, because you'll recognize straight away that's a sine graph, a cos graph, or it's a sine shifted, or it's a sine flipped with a minus a in front, or something like that, right? So let's have a look at this, okay? So we're going to have a look at that. Now, if I draw, okay, k as being greater than 0, so I draw sine of 2x or 3x, okay? What essentially are we doing? Let's just take a, let me just take a point. Let's just take a point, x and y equal to sine of, let's just call it 2x, okay? Well, 3x is also fine. I'm just looking for a number that multiplies or divides easily. So if x is 0, sine is 0. If x is 30 degrees, y is equal to sine of 90. Okay, isn't it? Sine of 90. So at 30 degrees, it's 1. Okay, at 60 degrees, it's sine of 180. Okay, 0. Hang on, 30, 60. So at 90, it's sine of 3 times 90, sine of 270. Sine of 270 is equal to minus 1. Hold on, let's draw this graph, right? This is even puzzling for me now. What has happened? So at 90 degrees, hold on, at 30 degrees, it's reached the peak of 1. At 60 degrees, it's 0. At there, it's now at minus. Look at the graph. Okay. So essentially, what is this graph doing? Oh, and it's going to be 0 there as well, isn't it? Okay. So what is happening? The graph is actually doing this, isn't it? So we have, we have squashed it. Okay. So if k is a bigger number, it means we squish the graph in. We compress it. So let's just make a note of that, shall we? Just put it into black. If k is greater than 0, we compress the graph. Okay? In other words, we do this with it, don't we? Well, what happens if k is less than 0, Okay, k greater than 1, come here, Kevin. K greater than 1. What if 0, k, not my best moment, is it? K greater than 0, less than 1. In other words, if it's a fraction, okay, what do you think we do? Well, yep, you're right, we stretch it out. Okay, we stretch it out. So therefore, what do you think it's going to be if we did a third? Well, it's going to be, this is going to stay 0, isn't it? Okay, and that's got to stay 0. Right? So therefore, when we got to, let's just plot it. Okay, okay, y equal sine of 1/3 x, 0. Well, if it was 0, if it was 90 degrees, it would be 30, wouldn't it? So at 90 degrees, we've got sine of 30. Sine of 30 is a half. Let's go to 180 degrees. We'll have 180 over 3, which is sine of 60. Okay, sine of 60 is 0.866. Okay, let's now move up to 270 degrees, okay, and 360 degrees. Well, if it was 360 degrees divided by 3, okay, it'll be at 270 is going to be sine of 270 over 3, which is sine of 90, which is 1. Ah, there we go. So we're at 0, a half, 0. Okay, at 90 we're a half. At 180 we're 0.866. Okay, at 270 we are 1. Look. Okay, so therefore, this is what we do. We stretch it out. Okay, so we pull the period. Okay, so therefore, we can say, therefore, K affects the period. All right, so we can say that K affects the period, can't we? Okay. Amplitude, we've done all that. K affects the period. Okay. Okay, so what we say is we say the new, just all you have to remember is the new period is equal to the old period divided by K. So therefore, if it was the normal, if it was a 360 and K is 3, the new period is 120 degrees. Therefore, we have squashed it up because that means it repeats every 120 degrees. If you go back, what does that mean? Well, look, this green, let's go back to our green graph, okay? Between 180 and there, so up to 90, so it's going to go down again, isn't it? Okay, and it's going to go down and repeat like this, isn't it? Okay, like that. So you can see we're getting into the one period, we're getting 3. Okay, we're getting all these other graphs coming in, aren't we? Okay, I'll check my maths just now. I'm more worried that you can see that we're getting more graphs squished into the same period. So therefore, the period of the graph has dropped. The period of this graph, okay, was there to there. So the period of this graph is 120 degrees because K was equal to 3. Okay. Okay, therefore, new equals, the old was 360. Usually the old one is the one that we start with, okay? Our sine, our cos graph, right? Over K, and that's what we have done with it, right? Right. Now, what do we need to do with all this, okay? You're going to be given graph. I'm going to do some in the exam prep, okay? I'll probably add in one behind this, another video. So what I'm going to do is go through and continue with this, with some examples with it. But at the moment, what I'm going to say is we're going to just essentially leave it and come back to it and put in some examples. But just remember, use the table X and Y. That is just a perfect way of doing it. And all you got to remember is plot your graphs. Keep your wits about you, obviously, but you've got the step function in here. And it doesn't matter if you put your step function at 15 degrees. The key here, okay, is if you've got a graph of y is equal to 3 sine x minus 30 degrees, put your step to make sure that you catch as many of those as possible. But you can put it at 15 because 15 covers everybody, covers your 30, your 45s, your 60s, and your 90s, okay? 15 step is a good one, okay? Worth using on that side. All right, so basically we've sort of gone through these, okay? A is the amplitude. If they said to you, sketch a graph of y equals 2 sine 3x minus 30 degrees. Basically, you start off with basic shape is a sine. Okay, so draw your sine as a basic shape. The next thing is you say, okay, I'm going to have to work out some steps, but this sine graph is it's a negative. So the sine graph has gone forwards 30 degrees. This 3 here is greater than 0, so it's going to squish it up. And that 2 means it's going to lift the amplitude up to 2. All right? Can you see? They're not difficult at all. Okay? So what do we have to do? Put it in your calculator and use it like that. Or draw your own table. Okay? Remember, you only have to do it between 0 and 90 or 0 and 180. And then you're pretty much done. Okay. Next, I'm going to carry on. We're going to do, as I say, I'll still add in one behind this of extra examples. The next section we're going to do is we're going to start trigonometry. And we're going to be looking at the basic angles, sine, cos, tan. Then we're going to be looking at identities, proving left-hand side, right-hand side. Then we're going to move on to trig equations. And this is a long section. You can see, look, this in my notes is like 25, 30 pages of just examples that we're going to do. Okay? Guys, practice one or two of these. Really, it's worth it. I know, I'm preaching. But do you know what? I want you to get great results. You want to get the best you can. And just by plotting one or two on the same axes, and use colored pencils. Change your color like I do on the tablet here. Because why? Because it shows, it focuses the mind. There's my, then you can see, look, it's squished. Look, it's moved forward, backwards, or the amplitude has changed. That's the way you do them. Cheers. Have a great one. Bye.